Hello, I will be starting in 2 minutes. If you have doubt, you can ask me uh, up till week 4. Okay, I have started the recording. Today my audio is on. Yes. Okay. We will wait others to join. Okay, so I will start now. It's 6. So last time I started something new in that I was explaining the subject and examples using comic book series. So the first comics, it had some characters, and so it is 2 hour long lecture. So I thought to make it interesting in such a way that nobody get bored. And so is my audio okay, or is there any disturbance? Okay, so I will start. So this is second part, and in the first part I had correlated Batman with order, Joker with chaos or chaotic system. Now we will, in this series we will introduce one more character called Two-Face, and in our nonlinear vibration it depicts pure chance. So this was the cover I designed. Okay. So anyone who knows the comics will know about these characters and what they represent. So the Joker is chaos, and the Batman is order, and Two-Face is just pure chance. Now the Joker, is it chaos incarnate? Question mark. So now our end topics are on these things. So I wanted to generate interest from now onwards, that whatever we are studying in this course will end us into something as deadly and as beautiful as chaos. So chaos is, as in chaos theory, is not necessarily the same as the bad. In the last comics I had correlated a lot with Batman as a order, and so like order is a good thing and chaos is a bad thing. So it's not necessarily the bad thing, or we can say destructive chaos as portrayed by the Joker. In fact, the paradox of chaos theory is that chaos is not actually random. Now here comes the random, which is just pure chance. Okay, so now that chaos contains order and the order contains chaos. So in many of the movies and comics you would see that always the counterpart of Joker is Batman and counterpart of Batman is Joker. So something like that is in a yin yang sort of manner. So we have in yin yang there is a day and night, some concept like that, and in which there is some part of day is getting into night and some part of night is going into the day, and it's called the morning and the evening slot. So those are things which in which they are all related. And now when chaos occurs, then the system is first of all bounded. So we are talking about deterministic chaos. So it is bounded, meaning it conform to an attractor as shown in the previous part, that the green line was just revolving around 2 points, so it was having two attractors. And so in the same time display it can go into both. Now it should be non-repeating trajectories. So if it's a repeating trajectory as shown in the failure 1 2 3 4, the last comics. So there we saw that it was having a fixed path, and it was repeating the same trajectory. But in a deterministic chaos, what happens that there is no repetition of sort, so things become random. So here comes where I am relating the randomness with the non-linearity. Okay, when the system is non-linear, so the solution can be random. The third thing is it is much sensitive to the dependence on the initial conditions. So if you change the initial conditions, it might be that you are in altogether different thing. Okay, so that is what is meant by sensitive dependence on initial conditions. Now the easiest example in our physics is of a chaotic system is when we tie a three pendulum together end to end. We will look at the example also where it happens. Now technically three coupled periodic oscillator. Now if you hold the top pendulum string and move your hand, and so it's like we are adding energy. So the bottom pendulum will potentially, like the most bottom pendulum will potentially be having a chaotic response. So the movement will completely be deterministic, like because we have a equation of motions, so we can find the responses numerically maybe. Then so if we can model it within three simple equation motion, we can do that. Then it is bounded because we know that the string won't break, so it can vibrate anywhere, but the maximum length cannot exceed the length of the sum of the length of the three strings. So that is there. Now the trajectory will never repeat exactly. So if you will observe the last the ball, that won't be the same trajectory as the previous one. So it will be, now if you will trace that thing, it can become a beautiful patterning within the chaos. So that is what our subject is all about, in which we will be looking in the final part of this course. We will be looking at those figures, and those are very beautiful form of art. And now any small change in that motion or any initial point in the time will make big difference in predicting later position. So always it depends on where it started. So you can determine the end by having this thought ki where it started. If you don't know where it started, it's very tough to determine the motion where it will end. So that is very important statement. So another way of saying D is that predictability. Now last time I showed you Gotham City having various villains, in that there were linear villains and there was non-linear villains. Now in linear villains, the thing was it was predictable in nature, so Gotham City Police Department was able to capture them easily. But in our case it is non-linear villains where we need someone to kind of get these thing into account and try to capture those villains. So last time we had just one villain as such, Joker. Today we will have two villains. Now Okay, so coming to back to here this text. mm, Another way of saying that small changes at initial point in time will make big differences is that predictability of the system decreases over the longer time span, such that the output of the chaotic system will often appear random. Now, unless you look at very long series of behavior, so if you will look the chaotic system for very long enough, you will see that it now doesn't have any pattern of any sort. It will be just going this way and that way. You won't be able to determine what is happening. So it's something like that in which you are tossing a coin and finally you are either getting head or you are getting tail. It is no in between. So it is purely chance that what will happen. So hence our villain Two Face come into the picture, which kind of decides the fate of the whatever he is doing on based of the tossing of a coin. So so in this comic series we will be introducing a new character called Two Face. Okay, this is one of the ways that researchers can distinguish chaos from randomness. Now, chaos is different, Joker, and randomness is different as Two Face. So, we do that by looking at how autocorrelation drops over time. Now, these are the topics which we will be covering in the later part of the course. Now, in highly chaotic system, the drop off is fast, and in low level chaotic system, the drop off is slower. So, these are the some of the characteristics by which we can say that it is more toward the chaotic or more toward the randomness. Now, finally, all of this means that things are not chaotic or orderly. Now, there is a range. Always there is a range, because if we discretize the system also, like done in the finite element method and those kind of thing in which we discretize thing, now that smallest size on which we have discretized, that is also kind of a parameter which gives us ki how much things we want into nature, like so accuracy. And so there is always a range. A system may be little bit chaotic if it's low dimensional. So just imagine, instead of 3 pendulum, if it is 100 pendulums and you are looking at the bottommost part, now it will have a hell lot of motion. So the point again is, it is defined on the simple basis that um, the it the last ball won't exceed the total length. Okay, but then also the motion is so random that it can go anywhere. Now in last lecture at the end, I have shown you a response, a green response, and I have correlated with that with Joker. That was the example from Lorentz attractor, and it comes from Lorentz weather forecasting model in early 1960s. So these topics are always in research. So if you take out any STM, in that any STM topic, there you will see that everything comes out to be nonlinear at the end, and you are always finding the responses of it. So now the funniest chaotic attractor to explore visually is probably a Mentalbot set. You can watch YouTube videos on that. It's just I'm getting you ready for this course, so in that you can have more interaction with the topics. So in that Mendelbot set, a mathematical fractal generated. So now there is one more topic called fractals. Now it comes just after the chaos in this course. So it is a pattern, beautiful pattern, and actually the art right now, the artists are using those things because it is given by the nature. So now when you iterate this equation, maybe start from some initial value and then plug into output as the next value over time, then plot the solution from different starting values as color code, you will get rich beautiful patterns that repeat at smaller and smaller scales. Actually yes, so but you can watch this in beautiful simulations. In you just take one nonlinear system and you put different initial condition, it will have a different set of pattern. So you can watch these YouTube videos, and in that you can find that infinite complexity that represent, okay, sorry, okay, where is it? Okay, so yeah, you can watch Mandelbrot in the YouTube. Okay, so now we can go into more advanced topic from just starting to understand what linear system is. Last time I asked a question that if you are a biologist and if linear is equivalent to cat, then what non-linear will be equivalent to? Actually, then finally I realized it's a very beautiful question, and in the way to understand what non-linear dynamics actually is. So we say linear dynamics and then we say non-linear dynamics. So it has the same meaning of talking about a cat and talking about non-cat. Now non-cat can consist of many different things, even you and me. So the point is that we are into much more bigger domain than the previous one, and lot of things can be understood and lot of things can be kind of enhanced in some sort. So the idea of something called structural infinity arising from the simplicity, infinite detail, inherent unpredictability in deterministic system, order and chaos being mixed together in the yin yang fashion, and so on, all are very deep. And actually, if you meditate on it, you will get more deep. So these ideas serve to draw many different type of folks, from mathematician to non-agers. So our own class will consist of people from varying backgrounds, and if you can, so I am hence I am putting everything in general. So there could be from mechanical department, then there could be from electrical department, there could be from physics department, and yeah, now psychology is also using this. So now there are a lot of questions in this course, and in this comic series I would be presenting and those questions and trying to find the solution out of it. So first of all, this chaos bad. Then does this type of chaos really match when we see the motive of the Joker? So what the Joker do and how we can correlate with the chaos. Then how is this type of chaos distinct from the principled order of the Batman and the pure randomness of Two-Face? So what the heck do any of these have to do with psychology? Because it's Joker problem was psychological, even Batman problem was also psychological, and we will look today that Two-Face has also a psychological problem. So if Heath Ledger, like he was the actor who did Joker part in movie, so he had some untimely death. So is something in relation with these movies? So that is also some question which would be covering in this comic series. Now these questions and more will be addressed in these comics. Stay tuned. So before going into and talking about all those things, first of all, let me ask you, how comfortable are you with this type of teaching? Anyone? Mr. Ajay Kumar or Mr. Abhishek Kumar Upadhyay? To be frank, it's good if you interact. Okay. Ajay Kumar interacted by going out of the meeting. Okay, I won't ask another question then. I will just put this video in YouTube. Okay, so now we have these different assignments assigned to us. Okay, great. Okay, great. Okay. So yeah, So we have different assignments assigned to us. So in given days we have to complete that. So assignment 1, assignment 2, last date has been passed, so it was 8th Feb. Now uh, the 4th Feb was my first class, first lecture on this example. Now this today is 11th Feb, and we would be covering week 1 maybe, and week 2 like maybe, but week 1 we will be covering using my examples. So let's see in next class if we can reach up to solution of nonlinear equations. So you all are would be watching the uh, YouTube lecture by Dwivedi sir now, and solving these questions. So I will be helping in some different sort. I would be giving you a different perspective altogether, because those questions are not that much tricky. What the tricky questions I will show you, like what actually these things convey in our at least in these comics. Okay, so the lectures we have seen would be introduction to mechanical system, then superposition rule, commonly used nonlinear equations, equilibrium points, potential functions. Then you would have seen different method for development of nonlinear equation of motion. So in that there would be force and moment based approach, then Lagrange principle, then extended Hamilton's principle, and finally use of scaling and bookkeeping parameter for ordering. Now in this class I have prepared up to, I will just give one thing back, yeah, extended Hamilton principle. So I have prepared up to that. We will catch up with other topics in next class. So I wanted to start formulation this time, and we will be doing how to find the solution of this governing equation in the next time. So week first was introduction to nonlinear mechanical system, in which lecture 1 was about introduction to mechanical system. I have just put them into one form, and you can write these things, but it's actually you would have already watched the videos, so it would be in your notes. Now mechanical system, they are of two sort, linear and non-linear, and elementary parts are stiffness, mass, and damping. Now forces consist of various forcing, so some are disturbing forces, restoring forces, inertia forces, damping forces. Now vibration can be classified into many different um classification. So free, force, in free there is underdamped, critically damped, and overdamped. We looked at in the previous lecture. Now it can be deterministic and random. This is our today's topic. Now it will be useful and non-useful. So in that I had some thought ki vibrations which are useful. So there are two instances which I know of. So it can be an interview question. So one is music. Now music is sort of vibration and acoustics. So but that has a perfect use. It kind of soothes us, right? So uh, it is useful. Next is energy harvester, going into more into electromechanical domain, in which we extract the energy of the motion. Then non-useful, you can list many. I'm just putting one for the shows, like bearing, in which bearing, if it's a friction, then you have huge losses. Now in that it is just the part where structural dynamics or the mechanical vibration was there, linear dynamical system. So we had a single degree of freedom, in that we learned harmonic forcing, rotating unbalance, base excitation, vibration isolation. Then we went to 2 degree of freedom, then from there we went to multi degree of freedom, and finally we learned how to tackle with the continuous system. Okay, so mechanical vibrations or any vibration in general have four components to it. Like if there is a system, now it can be any system. I am just saying the word system in very layman term, that a system, it can be anything. So first of all is, if you wanted to study a system, first thing which we do is abstraction. So today we will be doing some exercises in form of a hero, obviously you are Batman. So we would be abstracting some ideas, and then we would be taking out what we can find out of it. What we get is a equation of motion, and then from there we will go into how to solve those equation of motion, and then it could have various responses such as fixed responses, periodic responses, quasi-periodic responses, and chaotic responses. Finally, we will look at the interpretation part of it, what is happening and how we can actually use in the application part. So in potential question asked in lecture 1 were how to determine natural frequency from given response of the system. Now it can be natural frequency, damping, stiffness. So if somebody would have done something called modal analysis, he would know that if there is some physical system, we can abstract it and convert it into a model, and from that model we can find its responses, and there is a way in which we can come back from the responses to this model. So that is called modal analysis. So if we have some system and which is obviously vibrating, we can put the sensors on it, and we can take those responses and you can directly convert them into system parameters such as mass, stiffness, damping. Now second, we will look at abstractions today. So abstraction is a word in which we try to look the physical system in a way in which we can make it into a mathematical model such that we can achieve something out of it. Okay, that something varies to various extent. First of all, it can be the thing which you are looking for. It can be some sort of optimization. It can be some sort of, if you are analyzing, so there are a lot of topics into it. So we will look via the example. Okay, so there was a question that explain how energy transfer in simple pendulum consisting the system with or without damping. So energy transfer is again a concept in which we look at the energy as a whole as a constant, and it is just interplay in between with a exception of a damping forces which kind of take out the energy. Okay. Now there were a lot of MATLAB assignment. I haven't prepared MATLAB assignments as of now, but in future when we will be needing numerical methods, we would be doing that. So it will be like we will be in the bat cave, and our system will only have one software, MATLAB, and we would be performing different operations with that. Okay, so back to story number 1. Now the city of Gotham is in peril as dangerous mechanical shark terrorizes waters, sinking boats and endangering lives. Now Batman is determined to stop this threat and protect the people of Gotham. Now you can see I have just abstracted a shark. Okay, so as he begin his investigation, he discovers that shark had been created by one of his old foes, the Joker, because that is the only character I had come up with. Now the Joker has always been known as his twisted sense of humor and love of chaos, but this latest scheme was on another level. He has created a sophisticated mechanical shark to wreak havoc on the city and its inhabitants. Now Batman knew he had to act fast, so he suited up and headed to the docks. He climbed aboard a high-tech submarine, and he has designed specifically for the underwater missions, and set off in pursuit of the shark. Now, as he closed in on the shark, Batman could see that it was an impressive piece of machinery, and it was covered in razor sharp teeth, and its metallic fin slides through the water with ease. Now Batman knew that he has to be careful as the shark was armed with powerful weapon and could pose a serious threat to his submarine. Now this piece of machinery was based on biomimicry. So if anybody who would be interested in biomimicry can search that. it is in which we take things from nature and put them into the design, and it works perfectly because nature had been in this game from very long. It has perfected each and every being into what they are now. So what we do is just we take the design details and it's just copy paste of the design, and the thing works brilliantly. So now what Batman had to do is now he had to do reverse engineering of the reverse engineering, in that he have to take a shark and try to find what parts it has so he can find a vital point to attack that shark. Now for that, first we have to look how the fish moves. So a fish, it swims with rhythmic side to side S shape movement as shown in this figure. Okay, this figure, we will come to this. Now using their fins and body to push against the incompressible water. Now the paired pectoral fin, okay, I can use my markers here. So yeah, by red I will be marking things. So paired pectoral fins, so these are the pectoral fins. These are the pectoral fins. Okay. Okay, my system hanged. Back to action. So this is called pectoral fin. Now what else is information there? Now pectoral fin, on there are two pectoral fin in either side, and they are homologous to the forelimbs of the tetrapod. Tetrapod are something which is having four paws or four hands or four limbs, and so forelimbs is kind of our equivalent to pectoral fin. Now the paired pelvic fin. So there is a pelvic fin. We will use some other color. So this blue color is pelvic fin. Okay. Are typically located behind pectoral fin, and they are homologous to hind limb of the tetrapod. So they are like kind of our just like analogous to our leg. And dorsal fin are located in the back. Now there is a dorsal fin. So there are two dorsal fin actually. One is anterior dorsal and another is. So I will mark those. So this is all going into the Batman's head. Okay. So anterior dorsal fin and posterior dorsal fin. So they are located on the back. So like for our back have a backbone. So shark back is having two fins. Then it serves to protect fish against rolling and assist them in sudden turns and stops. Now caudal fins are tail fin used for propulsion, and this is our final caudal fin. So we have how many parts? 1, 2, 3, 4 parts. Okay. Now, despite the danger which the mechanical shark was causing, Batman was undeterred because he's a hero. Now he used his submarine advanced technology to outmaneuver the shark and disable its weapon system. So how he is doing that? By abstracting it. Okay. So we have a system here, the actual system, a shark, and we will now develop an abstraction that can be used to study the lateral stability in side to side movement. So in that we can actually attack the shark at the vital spot. So we would be finding, first of all, we would be converting the system into some form of mathematical system, and then we would be finding its weak spot. Okay, so movement is something like this. So it's a locomotion of any general fish, something like a snake having a fin, very dangerous. So since Abhishek is already moving, so I would be just carrying down with the solutions. You all can watch in the YouTube. Now it can have many solutions, okay, depending on what type of accuracy we want or what type of information we want. So for information such as vital spot, I think it is better that we look at the as a abstraction through beam. So we can first of all see that the back, like the main streamline of the body, it is, it's called a median. So median is idealized as a beam. So there is a beam, and in that beam two more beams are attached. One is pectoral fin, which is again idealized a beam, and the pelvic fin. Okay, so they kind of hand and legs. Now posterior dorsal and the anterior dorsal can be idealized as the point mass, because we are talking about the lateral stability. So it's like only this direction, not this direction, or not rolling polling, that we are not looking at right now. We are just looking at the lateral stability. So we are assuming that anterior dorsal and posterior dorsal and caudal fin doesn't affect that much to our lateral stability. Only lateral stability is so these assumptions which we are taking are part of the abstraction only. So it's like we can have a feedback mechanism in which first we talk about how we are putting the assumptions, and then finally we will be getting a solution. We will be checking it out, those solution with real thing, and then we would be taking precautions on those assumptions. Then we will again come to the responses. So it's a cyclic process. So now this is the one way to go. Now another way, so now if you wanted to find a weak point in the whole system, we can actually calculate it using finite element method or any software. But since if we don't have that much computing power, what we can do, instead of idealizing as beam, we can now take those fins as pectoral fins and pelvic fin as point masses attached with a spring. That is also a good way to go, but the solution won't be as accurate as the previous case. But still, we are just having an idea what is the weakest spot. We are not looking at how much that weak the spot is. So hence, in that again, what we are doing is we are idealizing a median with a beam. Then pectoral fin and pelvic fin are point masses having having a spring in between, and others are same as the previous one. So this is also one way to go. In this, what advantage we have, instead of solving for three beams which are coupled in some sort, we are now solving for only one beam attached to some masses and the spring. So we have less calculation to do, and in that way we can get this done very fast, which will be obviously needed in our, because shark is destroying our Gotham city. So now we can come one step more further, that we can put spring and masses all together everywhere. There is also a nice way to go. Now in this, median is now idealized as the discrete masses. So if you will put this system into the bat computer, I will say bat computer, so you will see that it will give the solution very fast, and hence we can find the weak spot of the shark by using this kind of description. Now we won't go into responses as such, because right now I am just one step before formulation. What we have to do is we have to abstract the situation. So what we are doing now, so with shark now vulnerable, okay, vulnerable, he prepared to board it and disable the control system from within. So that is what Batman is good at, infiltrating things. So now fight was intense, but Batman was able to overpower the shark's robotic systems and shut it down. So the city of Gotham breathed the collective sigh. Okay, this happened only in the comics. Collective sigh of relief as the dangerous mechanical shark was defeated. So as Batman returned to the docks, he reflected on the lessons he has learned from this experience, as you would also do. The Joker had once again showed that he was a master of chaos, making so a chaotic system, already a chaotic system, and putting mechanical parts to it. So, but Batman has proven that he was equal to the challenge. Now, he was defender of the Gotham, and he would stop at nothing to protect his people. So, in that way, our first story ends. So, you can put on chat, or I will just share my number, or you can just put suggestions for my first story. Okay, so this was about lecture 1. Now, lecture 2 was based on superposition rule, then commonly used nonlinear equations, and in the principle of superposition, we have checked for linearity. Like if these two conditions checks out, we can say that the system is linear. But our course name is nonlinear dynamics, so it is just to check whatever we don't have to do in this course. Okay, so yeah, linear system is very is a base by which we can go into nonlinear system. So first of all, you have to check this if it's a linear system or nonlinear system. So if these two conditions is not satisfied, we say that it's a nonlinear system. Now, commonly used nonlinear equation. So some example sir has provided in the course. So simple pendulum with having a base excitation. So pendulum is having a sine theta term, so which makes it non-linear in nature. Um, we can approximate that for small amplitude as a linear system. So that is the way in which we get the solution as two second order system. But that is not true, because okay, in next class I would ask 5 fundamental questions. In that you have to think practically, like what is happening. So these are the things which I have studied and kind of ratified in the whole of our life, but there are things in which we have to think practically. So maybe next class I will give you 5 different questions in which let's test you out. So for that you have to come to this session. If anyone, please come to this session. Okay, so there were various kind of systems, and we would be covering in further comics. So because it's just introduction to those system, but these system have huge implication altogether in many different fields. So we'll be looking at that. Lorentz equation I have shown you, and could be any other system also. Okay, so our story 2 starts now. In story 2, we are back with Joker. So Batman has finally caught the Joker after a long and dangerous chase through the street of Gotham. Finally, now Joker had been caught in an act of daring robbery and had nowhere left to run. Now Batman has finally cornered him and was ready to bring him to justice. Something seems odd because everything is going perfectly fine. So, but just as he was about to make the arrest, yes, we wanted this situation, the Joker pulled out a surprise of its own with a sly grin, the different kind of grin. So he hit a hidden switch, sorry, that opened a trap door beneath their feet. So both were standing on a platform which was movable. Now Batman and Joker fell into the dark, murky pit, landing in a large chemical drum filled with a strange glowing liquid. So something like this. Okay, so Batman, obviously it has some sensor. If he goes into water, the mask, a separate mask come into his mouth. So that thing comes into like it's a auto feature in his mask. So I will again say, to what happened, that they fell into a dark murky pit, landing in the large chemical drum. So also there is a strange thing. This drum was having the same chemical in which Joker once was having the chemical disfigurement. So hence it is special of its nature, this question. Now what you have to do is, we are analyzing the situation, what had happened. So we have just freeze the time for now, and what we are doing is we are trying to find that this drum is actually connected to a spring and it has a motion. So if it had been just a block of mass, it would be just a linear system, but there is a liquid flowing out of the system. Okay, so which gives this system, makes the system is non-linear, because mass is now, mass of the drum is now, Manjunath, can I mute you? Okay, so so consider a undamped single degree of system consisting of a tank filled with the fluid. That fluid is again that green thing, as shown in the figure. The tank rests on the wheel, so it is resting on a wheel and is restrained laterally by a elastic spring, so as shown in this figure. Okay, so this can only go this direction. Now we assume also that the tank has a device, say a membrane, that prevents any sloshing of the water of this fluid surface. Okay, I tried to remove water everywhere. Okay, instead of there, fluid is there. Okay. Fluid surface. So prevent any sloshing of the fluid surface. Now the tank has an opening at the bottom through which the fluid flows out perpendicular to the direction of the oscillation. Okay, there are more changes to this question now. So no perpendicular thing. This was the side of the bottom through which fluid flows out at the rate that depends on the fluid head. Now if we neglect the pressure gradient that rise in the fluid from the lateral oscillation of the tank, then the fluid flow is given by, now the fluid flow discharge rate is given by Qt is equal to A naught under root 2gh, in which h is the height of the fluid in the tank, g is the acceleration of the gravity, and A naught is the cross section of the opening. Now if A denotes the cross section of the tank, then the rate of change of h is h dot is equal to minus Qt by A. Now you can check those relations out. So what I am doing is I am making I'm using force and moment approach method to find the equation of motion of the system. So for that I need to know each and everything about the system. So hence I am trying to put everything into one relation. So we know that rate of change of the height of the fluid is h dot, and which can be written as minus Qt by A, which leads us to a differential equation for the fluid height. Now as the time passes, dt is equal to minus A by A naught under root 2g dh by dt. So we can easily observe by the figure that this thing is happening, how the time is changing, and from that time how the height is changing, and from that height how kind of it is the going out. Now why, if we integrate this equation, we obtain this relationship. So we will hold on to this relationship. Now we are beginning the observation. Now we had frozen the time. Now we will start moving the time, and so let's say if the height is h naught and we have defined a parameter A. So this is second relationship which would be using, like something A, which is just that term from here. This reverse of this inverse of this term. Now then we have under root h by h naught is equal to 1 minus at. Now this mass of the fluid is proportional to the height of the fluid in the tank. So if we have empty is the mass of the empty tank as well as all the attachments, and mw is the initial mass of the fluid, then the instantaneous mass of the system is supposed to be total m is equal to mt plus mw, and then in bracket 1 minus at whole square. So this is subjected to at less than equal to 1. Now what we are doing is we are using Newton's law now. So to observe the dynamic equation of the spring mass system, we apply next to the principle of conservation of momentum to the system as free body. So free body diagram comes here. So we are using force based method, and which will give result in this solution. Now here mass is not constant, so it's not single degree of freedom linear system. Instead it becomes a non-linear system. So if we will differentiate to simplify matter further, we shall neglect the mass of the tank in comparison to the fluid. Now we will just think that mass of the fluid is much more, and this means that our solution will be meaningful only for early time while enough fluid remains in the tank. Now that tank is actually very big, and both are drowning there. I think only one is drowning already. Joker had it has a kind of immunity to that fluid because he was made from that fluid. So enough fluid remain in the tank, that is while at very less than 1. Now the dynamic equilibrium equation then reduces to this equation. So what we have done, we have neglected mt. So mt is neglected, only mw remains, and mw we know by this. So this gives us our this equation. Okay, so this is part up to where we are finding equation of motion. So this is our equation of motion. Now if it had been a linear system, it would be very easy to find its responses, because we can then assume some sort of solution and then move forward. We can move forward in this case also, but again it is mathematically very hard to do that. You have to be a mathematician of some sort. So my point is, if we are going for solving a nonlinear system as the exact solution, it is very tough to do. In some cases it can be done. So this is one case in which it can be done. Let's say our Batman has knowledge of this case, so he will be helpful. So according to mathematical domain, this equation admits a solution of form. Now how do one person know what kind of form of solution? So for this I have to go to mathematical domain. Now so form of solution is something in which we look at the equation, what kind of equation it is. So and we have classified those equation into many different sorts. So those are called archetypical equation, and if we use any archetypical equation, we can form a solution form. So that is it's like we are taking one system of equation in which we know the exact solution. We would use another analogous system, and then we would be putting those two systems together and trying to find out how we can convert the system to that system. Okay, so this has huge application again in many field of research. Now finally here, this is actually above my head also how this is happening, but I just wanted to show you that the exact solution can be found out using mathematics alone. We don't have to go to numerical method in this case. Okay, so this is our equation of motion, and then we have defined something called initial natural frequency. Now this is a system in which natural frequency change. Okay, so our natural frequency is changing as the mass is going out. So many people would say that how natural frequency can change, it is fixed for some system. But if system is altogether non-linear or something, it is changing inherently, then the nonlinear, the frequency also, natural frequency also changes of the system, just like our body. If uh, otherwise there would be one fixed frequency which would have destroyed us, okay, but our system is always changing in configuration because you are already made of fluid, so hence nothing affect our body. But if you take a glass and you give a fixed frequency which is equivalent to its natural frequency, it will break. Okay, so this gives a nice insight that if system is complex enough, it has a capability to kind of not destroyed by the vibration. Oh, so this is very complex. I have just put as a solution, but don't bother. I just wanted to show that the solution form is something like this. It can be found. Okay, with some constraints. So which I am. So yeah, so solution will be some this sort, and what Batman does is directly using these results, and what he is doing further is, Batman was disoriented and dizzy because some of the fluid went inside, but he quickly realized that he was in a dangerous situation. So the chemical drum was starting to heat up also, and he would feel the heat and pressure rising. He knew that if he didn't get out soon, he would be burned alive by the dangerous chemicals. Now, the Joker, on the other hand, was laughing hysterically. He was reveling up in the chaos and destruction that he has caused, and he was in no hurry to escape. Batman realized that Joker was just trying to buy time and that he would eventually come up with a way to escape and cause more trouble. So, with no other choice, Batman steeled himself means being brave, and started to work. He used his utility belt to create a rope, and that would reach the top of the pit, and he used his grappling gun to climb out of the chemical drum. So, this information, since the drum is also moving, so what I have designed this comics into it. Um, so he knows the responses now, okay, how the because of spilling of the fluid, how the responses will be. So he know the initial conditions from where he started. He put those initial condition into this uh, exact solution, and he found out at what point the grappling gun would work, and it will get attached somewhere, which is a very vital spot of the maybe. So he uses utility gun to create a rope that would reach to top of the pit. So reaching at the top of the pit is something related to what the response is which we have just found out. So he could feel the heat and pressure growing, but so we are making the situation tense, but finally he will get out, I think. Okay, so these are some of the comics script. So he's saying damn it when he's just going down. So he's now doing a lot of sci-fi things. So he's setting propulsion tunnel to non-viscous. Okay, that is okay. I cannot think about non-viscous fluid. Everything is viscous. Okay, so it's air. How can 750 psi burst. So he's doing some sort of thing. Now space enclosed and pressure seal injury to the user will be, now he said override, like the computer is saying now he said override whatever computer is saying, so he can take all the pain, that we know. Now I know its component by heart, the whole list. Now he had researched once into how that liquid, the fluid in which Joker drowned. So 11% sodium hydroxide, 34% sulfuric acid. Please don't make this. Okay, 5% chromium solution, zinc sulfide doped with copper, which gives it's a green glow. Okay, we know how it gives a green glow. But even so, some afternoons when I can't sleep, I take out a old slide and study it all over again. So he kind of study that part of the slide in which those liquid were there. I look for something I missed, some secret ingredient, the thing that made him. Now that is the point which I was covering in the last comics, that something in that chemical plant made Joker, right? So some secret ingredient is still missing. So you can now nonlinear dynamics. You can give that past is also there, which kind of gave uh, Joker this power of defying logic. So I stare until it's blurred and I'm looking at nothing, looking at myself, my own eye, reflecting back from the lens. So here what order and chaos, like chaos and order and chaos. So these things. So why I included this part of the comics was it was just relating to what I was saying. Now there is nothing in this mixture but death. So yeah, this is another philosophical view to put. Now, finally, he made into the top and emerged from the pit, gasping for air. He looked back down to Chemical Drum and saw that Joker was still down there, laughing maniacally. Now, Batman knew that he would have kept an eye on the Joker as he would show that he would escape and cause no more trouble in the future. Still, there is some part I think left. Yes. So something nobody should be able to survive. So he just came out of the fluid drum and he's making sound. Okay. Now he's just scanning for the heat signature. Where is the Joker? So scan impossible, damage assessment irreparable. So as we can see that Joker is vanished and whatever the scanner problems were, they were irreparable. He had to buy a new scanner. Sorry. Okay, so okay, I have to change the story part. With Joker in customer. Okay, just Batman returned to the Batcave to study the chemical drum and figure out what kind of chemical it contained. Yes, he realized that he had narrowly escaped a dangerous situation, and he was grateful for his quick thinking and resourcefulness. Thanks to us, he vowed to always be ready for whatever the Joker threw his way, no matter how dangerous it might be. Okay, so this kind of gives us the second end to the second story. So again, please comment on this story. I have put a huge effort to go through a lot of literature surveys. I have to read comics, nothing else. Okay, moving forward. Now, potential question which were asked in lecture 2. So, how to determine critically damped system, underdamped system, overdamped system from given parameters M, K, and C. In last class, we have checked those out, like how the system can be classified as critically damped, then overdamped, and underdamped. Then again, we will look at the abstraction. Then different type of damping. So different type of damping is a force of structural vibrations only. I won't touch that. We will be playing with the viscous damping in this course for some part. Now study the cause of nonlinearity in the vibration system. So this is again a MATLAB, I think. So we have to plot magnification factor versus frequency ratio for a single degree of freedom and 2 degree of freedom. Then plot curves to show vibration isolation in single degree of system. So I think sir has shown an example of vibration isolation in which he has attached in one singular degree of freedom additional mass, and then he has commented on how we can do a vibration isolation using the additional mass. Maybe if time permits, I will be doing the next class, but for today I don't have that. Now find model frequency and normal modes of a double pendulum. Okay, then plot the mode shape of the cantilever, fix, simply supported, and free beam. So all these questions can be easily done. If you have any doubt, you can just put in maybe discussion forum, or you can just contact me. I will be giving the solution. Okay. Oh, third story started. Okay, 7 o'clock, 7:02. We have 58 minutes to go. So Gotham was in peril once again as a new and dangerous threat has emerged. This villainous Two-Face. Now we have Two-Face into the picture, but it is not of that sort of, but let's take Two-Face, and created a massive mechanical cheetah dubbed Mecha Cheetah. Now to wreak havoc on the city and its citizen. Now instead of shark, now we have cheetah. Now since same villain will be bad, so I took a new villain. To wreak havoc in the city and its citizen, Batman was determined to stop this threat and save Gotham. Batman quickly go to work studying the Mecha Cheetah as he had done in case of Mecha Shark, and looking for its weaknesses, he discovered that the cheetah was powered by a highly advanced energy source, and that if he could find a way to disable that power source, he could stop the Mecha Cheetah. Now today what our task will be, we would be again abstracting a cheetah, and in that we would be looking at what is that source, what it's talking about. But getting close to enough to make a cheetah to disable its power source would be no easy task, because the cheetah was fast and agile, and it was armed with variety of dangerous weapons. Batman knew that he would have to be careful, as one wrong move would mean the end of his mission and destruction of Gotham, because he would be dead, and then the Gotham city will be ravaged. Now, determined to save the city, Batman set out to confront the Mecha Cheetah. The chase was intense, so I can put the question in front, that what is that weak spot. We will look at the motion of the cheetah and then we will comment. As the cheetah raced through the streets of Gotham, leaving destruction in its wake. But Batman was just as determined, and he was able to keep pace with the Mecha Cheetah. As the two clashed, Batman was able to get close enough to the Mecha Cheetah to disable its power source, and the cheetah now powerless, Batman was able to bring it to a stop and save Gotham. So this happened in the real time. Now we are stopping at the point where cheetah is destroying things, and we are analyzing the cheetah. Okay, this is the animation. So this is our cheetah. It will play now. Yes. So let's say this is a cheetah. Can any of you tell me what is power source? Like power source, why cheetah is the fastest animal in the earth? In land. Yes. Anyone? Hello? So my question is, yes, yes, Abhishek. Okay. Oh, okay. Yes, flexibility is there. That's great. You just pinpointed why cheetah is fastest thing, because of flexibility. What actually happened in the flexibility, I can give you nice, Abhishek, because nobody gave me this direct answer up till now. You are the first. Okay, great, nice. So yes, so because of the flexibility, it is like something of flexion and then extension. So both legs are like all four limbs and hind limbs are working together. What happens that it gives that backbone of the cheetah is now, if we can idealize as a beam, we can see it stores energy and then kind of eject energy, store energy then eject energy. So that's a very harmonious way to do something, because there is no kind of spilling of things. So hence it can the cheetah body can store energy in its form only, and then it releases by extension. So great. Oh, so this is one of the abstraction, and in that cheetah is idealized as a beam and with a hind length. But mainly what we have to analyze is that beam, how much beam is storing the energy and how it's ejecting that. So that is like utmost ultimate thing about cheetah. Okay, apart from its hearing senses and eating people, or not eating people, eating animals. Okay. So Two-Face was furious as his plan had failed, and he vowed to get his revenge on Batman. we will see further how he do that. Now, but Batman was ready for anything that Two-Face would throw at him. He knew that he would always be defender of Gotham and that he would stop at nothing to protect its citizens. I am repeating this line in every story. Wow, Batman is not dying. Okay, so we are in lecture 3. In lecture 3, we saw things about equilibrium points, potential functions, and we saw that there are 4 kind of responses in a nonlinear system. First is fixed point, in which either it go to stable point, in our case is generally rest, the system goes to rest. If it's damped and linear system, so something of those sort. Now it can be periodic. The one example is having a limit cycle oscillations. It can be quasi-periodic. Quasi-periodic is something which is in between chaotic and periodic. Okay, we will be looking at these type of responses in the later part of the course. Now, sir also mentioned something about qualitative analysis of nonlinear system. We had something called potential well concept, and at that point I can ask another question. So we know that total energy is constant. Okay, so can you relate this point with something called invariant and something called pattern? So this is much more basic than our mechanical system. In our mechanical system, something is called Hamiltonian. Hamilton is a person, great mathematician and physicist. So Hamiltonian, this is a function in which that is equivalent to h, obviously, which says that kinetic energy and potential energy is constant, like when they are added up. So this is called invariant. So in nature, if you see any pattern appearing anywhere, so now pattern I am saying it can be any pattern. Okay, like something which is basis of something and the pattern appears, then there should be some invariant in the field. If we can find that invariant, we can actually know how the system behaves. So that is also one beautiful way of a perspective of seeing things. So great mathematician, neither she was woman and she was in she's a mathematician. She gave this theory that she was a mathematician and she gave a beautiful theory that if we have pattern anywhere, then there is always an invariant associated with it. In mechanical system, we have that energy. We can say that there is an energy, and no matter the system is non-linear, but if energy is constant, we can look into many things about that. Okay, so neither she's a mathematician. Okay. Now potential question asked in lecture 3 was, write down 5 applications of Duffling equation, Rayleigh, Van der Pol, Matthews-Hill equation. We would be doing this for sure in next classes. Next is how to distinguish between fixed point, periodic, quasi-periodic, chaotic. For now, let's say fixed point is something which comes to rest. Periodic is always moving in a cycle, predictable. Then chaotic is non-predictable, but non-predictable. It's like when it will repeat, we don't know. quasi-periodic in between these two. Okay, we will be looking at that in the later course. What is the limit cycle? As I have mentioned, limit cycle. Then sync. Now limit cycle is, let's say this is a phase space. Okay, phase space you would have covered in the course, and let's say we start here, okay, at this point. Now it can be that system is something in which it goes like this, going into some sort of one orbit, then it's called limit cycle. Okay, sync means if there is one point here, one point there, one point here, and let's say this is the attractor, so everything will come to this point and then kind of rest there. So this is called sync. The source is anything which starts will kind of have a spiraling motion of some sort. Okay, so having a source kind of behavior, throwing things out. Now stable is in which everything is bounded, and unstable response is if it's not bounded. Now there was mention of MATLAB code on the basis of OD45. You can practice those, or you can use ChatGPT to write the codes. So you can use Excel file also. So now MATLAB has different plotting software, so you can use those also. You don't have to come to Excel file, but yeah, it depends on the how in the course it is used. So hang on to it. Okay. Now from that we came to week 2, development of nonlinear equations of motion using symbolic software. Okay, I should remove the symbolic software. I'm not using right now this. I'm just into the formulation. So lecture 4 is about force and moment based approach and energy based approach. One second. So sir showed 2 ways. One is called lumped parameter model and one is distributed mass model. Now I have just shown you these two systems in that shark problem. In shark problem, when everything was converted into point masses and spring, then it's called lumped parameter model, in which whole system is converted into some fixed point and then stiffnesses are attached to it. So these are called lumped parameter model. Then there is distributed mass model, in which we can idealize it as a beam only or some continuous figures. Okay, so today what we will do, if time permits, we will go into example where we can interchange in between these two. Okay, and this is a basis of finite element method. If a distributed mass model is there, and if you can chop it into smaller pieces, and then those pieces if you can put it into some sort of discrete point, then we can convert the whole system into those points information, and we can finally find the responses by making a huge matrix, and in one shot we can find the solution. Okay, now we had this, which, okay, I can do one example of it, but I won't go into detail because this is what we are learning from our childhood. Now this is very important because we are not used to it, Lagrange principle, but it is very much used in scientific community and research. Moreover, that something called extended Hamilton principle, that is used much more. Let's see if we have time today to cover that. Okay, we are into story number 4, I think. Okay. Batman was in Batcave working on a new project. Oh, he got a new project, just like we get a new project. It's a research scholars. So he was developing a special forging hammer that would allow him to forge new and improved weapon to help him in his battle against the villains of Gotham. Now there is no villain here right now. What he is doing is preparing himself. So as once I have heard, I'm going philosophical now. So once I've heard thought by, it was written APJ Abdul Kalam sir, but I think it was given by somebody else. Like when you are anvil, you have to kind of be, you have to be anvil sometime, and when given a chance, you have to be hammer. Okay, so this is a problem of anvil and hammer. So it's like in your life, you should be like anvil. You should get beaten up, and then when the chance arrive, you have to be a hammer. So this is mainly for the preparation when we are preparing for our exam. On that point of view, we had to be an anvil. Every day we had to do some sort of full routine problems, and we have to kind of go through a lot. But the uh, when an exam appears, which in which we had to be a hammer, we have to be a hammer there. We cannot be anvil then. Okay, so it's like when the interview happens, we have to be hammer there. Okay, we have to show ourselves, we have to present ourselves. So that's the thing which have inspired me a lot. So okay, so this problem has nothing to do with that. So we are just looking at an anvil. So but as he worked, he noticed that there was a problem with the hammer. It was too stiff, and it was able to transfer enough energy to metal that he was trying to forge. So there was no so it was like sonar and lohar. Okay, like there is something, some force requirement is there for one who is iron smith, and there is little force requirement who is goldsmith. Okay, so it said that 100 of blows of goldsmith is equivalent to one blow of a iron smith. So similar example, he needed something optimized in between. So this meant that he wasn't able to forge the weapon that he needed to protect Gotham. Okay, so he wanted something in between the ironsmith and the goldsmith. So determined to find a solution, Batman began to study the mechanics of the forging hammer. So he went into the mechanics. Now it's our domain now. He quickly discovered that the stiffness of a hammer was the root of the problem. Okay, the stiffness of the hammer was the root problem. So stiffness, we are actually working on stiffness, and that he needed to find a way to make a hammer more flexible. Now making a hammer more flexible, how it is, let's see. After conducting some experiment, he did some experiment, but I have to remove this actually. Yeah, theoretically. So theoretically, Batman realized that he would create a bilinear stiffness system. Now, what bilinear stiffness system is, I will explain you in this. This would allow the hammer to have a different level of stiffness depending on the amount of force that was applied to it. The result would be a hammer that was able to transfer more energy to the metal and forge stronger and more effective weapons. With this new system in place, Batman was finally able to forge the weapon that he needed to protect Gotham, and he was proud of his work, knowing that he was found a way to improve the abilities and make the real difference in the fight against the crime. The last line are very inspiring. So, okay, so what actually the problem he solved was a forging hammer, as shown in this figure. This was in the Batcave, hence is the dark there. Consists of a frame. Now there is a frame. I will try to. So this is a frame. I will color those things. Okay. So this is a frame. This brown. A falling weight known as the top, and in our case we are telling it as a hammer. So this is our hammer. This is our hammer. Okay, then an anvil. This is our anvil, which is already shaded, but I will shade it again. This is our anvil, and the foundation block. Now foundation block is a huge thing here. Okay, it's already done, so we don't. Now the anvil is a massive steel block on which material is forged into desired shape by repeated blows of the top. the anvil is usually mount. You can change this stub to hammer. So this is hammer. This is also hammer. The anvil is usually mounted on the elastic pad. So there is one more thing called elastic pad. Let me shade that. Pink color is already used. You can take this yellow color. This elastic pad. So this is the main thing, the elastic pad. To reduce the transmission of the vibration to the foundation block and the frame. The anvil and the foundation block are quite stiff compared to the elastic pad and the soil. Now, first of all, you will represent the system as 2 degree of freedom model by consisting the weight of the frame plus anvil and the foundation block separately. We can assume that pad is composed of linearly elastic material. For first case is question about linear system. We have to convert into linear system. We have to abstract them into linear system. The second is, now suppose that elastic pad is composed of a bilinear material that has a force displacement curve as shown in the figure B. So this is how the force relation should be. Like as we increase the displacement of the elastic pad, the force at one point where it's delta naught, the stiffness should change. Okay, change in such a way that the K2 is much more than K1. So this will give, like if something is pressing down, if it's pressed furthermore, it has much more greater stiffness than, so it's a hardening kind of statement. We are hardening the thing. Alright. Okay. So first one is easy. Okay, second also I will read. Now suppose that elastic pad is composed of okay, I have already done. Modify the abstraction in part A to reflect the change. In part A, it's simple. We have to put a hammer. So as the anvil and foundation block are quite stiff as compared to the elastic pad and the soil, we can make a linear system like this. So it's a 2 degree of freedom problem. Then bilinear stiffness will be something like this. Okay, this is the solution actually, which we are giving to Batman, and Batman will be making something like that. So finally, our modified result with bilinear stiffness will be like this. Okay. So in this, if I will make successive changes to this, after some point it will come like this: compression, 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 compression. At this point it will have K1 stiffness only. So at delta up to delta naught it will have K1 stiffness, but as E kind of goes to other part, when he reaches at this point, now you can see it will have a equivalent stiffness of K2, because when springs are in parallel it will give just some summation, right? So it will be K1 plus K2 minus K1, so it will be K2. So now up to here it will be K2. So this is bilinear stiffness, and it is in research again. Okay, so this covers, have I used so force approach method, one example that fluid tank one. Okay, I think second comics, second storyline. So we will move to Lagrangian way. So first of all, this is this topic has lot of branches, and let's see how much I can teach you. But the thing is, Lagrangian equation has lot into it, and it is being modified till now also. The research has been going on, and the thing is about constraints. So every system has some constraints, some sort of constraints, and we can actually form a system as well as constraint with help of something called language multiplier. Okay, so we will be looking at this. For that, we have to first understand what non-holonomic constraints are. Obviously, it's a non-holonomic, but what is holonomic? Okay, so anything which cannot be of this form. It is also called Pfeffin form. So, if anything which cannot be of this form, it can be called as non-holonomic constraint. So you can observe. So it is constrained on velocities, and the a ji's, these are coefficients, and also there is a tj. So ji is interdependent between the velocities, and tj is dependent on the time itself. Okay, so actually q here are velocities, so you will check this for this system if it is non-holonomic or holonomic. So there is a necessary condition for general form to holonomic. So this is our general form, and if this condition exists, then we call something condition for exactness for differential form. So I have told you we can find out some kind of solution form. So we can talk about that if we have this exactness into the picture. So this is the condition for this exactness, that okay, this is too much mathematical into nature, but hold on to it. I will be just giving you ideas on where to apply Lagrangian equation and when. So this is the first thing which will be covered, key constraints. So constraints are of two type, one is holonomic and one is non-holonomic. Holonomic constraints are easy to tackle, and we have some example in which we will be giving. So there are two type of thing. One is called physical coordinates and another is called generalized coordinate, right? And these generalized coordinate are something which doesn't have constraint coordinates into the picture. Physical coordinates can have as many equations, as many degree of freedom, not degree of freedom, as many coordinates. But if we talk about generalized coordinate, it should be degree of freedom like which is independent. So there shouldn't be any constraint. So if two coordinates are interdependent on each other, out of only one should be there. So that is what generalized coordinate tells us. So okay, great work till now. Let me show you example where Batman also defy logic. So since we are becoming mad day by day in this comics, like I am becoming mad day by day while making this comics. So now I have also a way to defy logic. Let me show you. Okay, so in this case we would be designing this bike. Okay, and this is actually a bike from a Tron series. It is again a different universe. So in that we go into matrix, we go into computer, and then we play game in real life. Okay, so we would be doing that, and we would be first looking at the constraints, what the constraint actually is. So why I have taken this, because visualization is very easy. We have axis already made, and we would be talking about how this bike behaves. First of all, the first constraint is that this bike is always is at z, so z is equal to 0. Z in our case is going up, so this is always in this plane. As you will see, this bike is always on this plane, x plane, oh, x and y plane. Let me define the axis first. This is one direction going up, this is another direction, and finally, okay, so this is z direction, this, let's say x or y, one second, this is x, this is x direction, and this is y direction. Okay, so just visualize like this. First constraint is bike is not going up, so it's not jumping. Alright, so bike is not jumping, so that is first constraint. So it is always constrained to a surface, so that is our first constraint. Z is equal to 0, so we are on the x and y plane only. Now second constraint is the length of the bike is constant. So if we will look at the, if you want to find the velocities, oh sorry, not velocities, if you want to put those coordinates into picture, then let's say x1 is equal to q1, y1 is equal to q2, z1 is equal to q3, x2 is equal to q4, y2 is equal to q5. So we have defined 6 coordinate systems. In that we are putting this constraint that x2 minus x1 का whole square plus y2 minus y1 का whole square is equal to L square. It's like distance between these 2 points in between the tire is same. So this is our second constraint. It necessarily means that the bike doesn't elongate itself or it becomes short. So there is no suspensor at this play. It's just a fixed rigid link. Okay, so this makes us constraint number 2. Now comes constraint number 3, which is more important. And here we have to give some. So this n, actually n vector is this n is actually coming out of the screen. Okay, so n is like in y direction, our y direction, and it's coming out of the screen. So z1, z2 all are defined. Now constraint 3, what it says that the if body is moving like this, okay, if the body is moving like this, it cannot move like this. Okay, so if this bike is going like this, in the screen you can see, if the bike is going like this, it cannot move like this or move like this. So lateral displacement are not allowed, alright, because of the formation of this bike. Now this is why it is there, because it gives us slippage and those things. Without slipping, we have to move. So in this direction, lateral direction, we don't have to put any slipping. So how we can make that? We can say that velocity in any direction and normal to it should be 0. Okay, that normal we know, and by equation if we put, we can have this third constraint equation. So we have 3 constraint equation. One was this, okay, not put, I will just put number, or this is the first constraint, this is second constraint, this is third constraint. Okay, now mic breaking phenomena, like now Batman, I will show you Batman define this constraint number 3. Okay, first constraint can easily be defined if somebody is pulling bike into air, but yeah, that is not, that will be cheesy thing if I would say that Batman can do that. The second is where elongation can happen. Now again, Batman bike has some elongation. Actually, when we had last class, we had discussed, we were designing a shock absorber which was doing this kind of behavior. Now third is more important, like, so this is that reveal. Okay, let it sink. You can see in this, Batman is going sideways because the tire is kind of revolving. Yeah, we actually made this bike, so yeah, that's our good thing. We are defining logics now. So if there would be a huge class, there would be a lot of applause, but okay, I will go with. Okay, so now we will look if these can be formed into Pfeffin form or not. So to do that, we have to first write those equation, and we have to find the differential of it. If you find the differential form and if it exactly satisfy those exactness equation, we can tell that this is holonomic constraint or non-holonomic constraint. So in this case, it's lot of maths now because we are finding differentials of everything. We say that the third constraint is actually doesn't satisfy, but constraint number 1 and 2 satisfy. Okay, so this is just I'm just wanted to tell you about what equation of motion. If you are finding equation of motion using Langevin equation of motion, that differential form, which actually I have somewhere. Okay, this form, this equation, if you are using, then what we have to consider and what not we have to consider. Okay, so first you have to check for the constraint. If those constraints are non-holonomic in nature, then we have some problem. If it's holonomic in nature, we can easily solve the problem. Okay, so now let's come to story number 5 or 6. I lost the count now. Okay, so Batman was, I will go like this, maintain a suspense. Batman was on the trail of Two-Face once again. Now Two-Face, you remember? Now this is the main question of Two-Face. This I designed. The villain has escaped from Arkham Asylum and was wreaking havoc in the street of Gotham. Batman knew that he had to stop Two-Face before he could cause any more harm to the city and its citizens. So as he closed into Two-Face hideout, Batman could hear the sound of a coin flipping through the air. Now I told you that coin, even my front page today has the Two-Face flipping a coin. So flipping a coin means pure, leaving it to pure chance. Okay. He knew that this was a Two-Face signature move. Okay, if anybody is Batman fan, he would know that always Two-Face has a coin, and that coin both have same thing. So both have either tail or head. I think both have head. Okay, so Two-Face knows the outcome. Two-Face knows the outcome because this is the only outcome. So, but let's take a coin which is having only one face. So no, having two faces, different faces. Okay, so and Batman steeled himself for what had to come. Again, there is a stealing had been done, so he is brave enough now. When he burst into the hideout, Batman was confronted by the Two-Face, who was standing in front of a pile of a stolen jewel. Now, flipping his lucky penny back and forth, heads or tails, Batsman, he asked. Two-Face said with a smirk, I will give you one chance to decide your fate. If you choose head, I will let you go, as if. And if you choose tails, well, let's just say that you won't be living here in one piece. Okay, this is only I could come up with. I'm not a. Okay, so Batman knew that he had to make a choice, and fast. He would try to take Two-Face down by force, and that would be risky. Or he had to trust in his own luck and choose his tail, hoping that Two-Face coin would land on the heads. In that moment, Batman realizes that he couldn't rely on the luck, he had to rely on his own skill and determination. He stepped forward and grabbed the penny from the Two-Faced hand. The fate of the Gotham doesn't rest on the flip of a coin, he said. It rests on the action of its heroes, and I am that hero. Okay, I think I changed my story at the end. There is one between. Okay, what happens here is instead of tossing the coin, he just rolled that penny, rolled that coin. Okay, and now it said it will be either head or tail. Okay, so the question was something like this. So yes, so rolling a penny. We come to rolling a penny. I will just add rolling a penny had to be added. Now, yes, in this question, this is the main question, that if a coin is rolled, okay, now it can be in either left side or right side. It can fall in left side or right side, right? Now, it depends on the contact point actually, that where it will go. And this is one of the non-holonomic constraint which I was talking you about, and these relations are followed there. I won't go into the detail, it will be very boring, because it's all equations. I will just tell you the interesting stuff, that it can go either way, right? But equation of motion, if you will solve properly, you can know where it's going and in which direction it is tilting, and you can actually, if you give little trick to it, you can actually predict what is happening. Okay, so in that way, Batman beats um, Two-Face. With that, Batman sprang into action, takes down the Two-Face and recovering the stolen jewel. He knew that there would always be new challenges and new villains to face, but he was ready for anything. The fate of Gotham was in good hands. So yeah, again there will be new villains, new sort of stories. So this is the, I think, final story, but still Batman is not out. We would be covering. Uh, yes. So Euler language equation without constraint, or if you speak about independent generalized coordinate, like already we know the independent generalized coordinate, we can directly write the equation like this. But in presence of non-holonomic constraint, the generalized coordinate are not independent. That is the, like, not generalized coordinate, the physical coordinates are not independent. So it is dependent on something else. We need some more relations, or we have to look into more perspective of things. Okay, so if you have non-holonomic constraint, just don't run, but go into more detail what is happening. Now let's say there are m non-holonomic constraint of this type. Then since virtual displacement take over constant time, we can vary the path from actual motion by replacing the constraints. Okay, so here comes what is called Lagrange multiplier. Oh wow, it created hexagon. So this is called Lagrange multiplier. Don't worry, these are all not in the courses, but in general I am giving you description about when to use Lagrangian equation of motion and when not to use Lagrangian equation of motion. If you use Lagrangian equation having the non-holonomic constraint, it will be very tough, and you will be having troubles of lot of sorts. But if those equation have constraint, if those system has constraint which is holonomic in nature, then you don't have anything to worry. You can directly use the formula. So if it is there, the constraint, then we have to follow this instruction. So Lagrange multiplier and Ci. Now Ci, which is constraint forces, which have to be put like this, and from where this will come, this lambda I, lambda j is from these conditions. Okay, this is the same condition which we have talked before. Oh, there is one more story left. Okay, let's go through it quickly. Batman was on the case of mysterious theft at a local science museum. The thief has stolen a valuable artifact and made their escape by sliding down a ramp on the roof of the museum. Batman was determined to catch the thief and retrieve the artifact. As he discovered, as he arrived at the scene of the crime, Batman noticed a block of wood lying at the bottom of the ramp. He realized that this must have been what the thief used to slide down the ramp and escape. Batman decided to put his physics knowledge to the test. What we will do now? He knew that the force of the friction acting on the block would determine its speed and its slide down the ramp. If he could calculate the force of the friction, he could use the information to catch the thief. He quickly got to the work, used his gadgets to measure the angle of the ramp. That can be easily done. The mass of the block and gravitational force acting on it. Okay. With this information, he was able to calculate the force of the friction acting on the block, determine its speed, and its slid down the ramp. With his calculation complete, Batman was able to predict the path of the thief and intercept them before they could get away. He retrieved the stolen artifact and brought the thief to justice, all thanks to his understanding of physics of a block sliding down the incline. So it's a classical problem. I have just made it into a Batman story. So we have a block sliding in the incline, and the incline is also sliding on a surface. Okay. So mass m2 slides relative to m1, which is turn slide relative to the horizontal surface. So case A is when surfaces are frictionless. Now case B is when there is a presence of a Coulomb friction between these two blocks. So for the above cases, find equation of motion, acceleration x1 as shown in the figure, and constraint force between the block. We actually need constraint force between the block, which is a huge question. One in which surfaces are frictionless and another in which the presence of Coulomb friction. So first of all, we will do some we won't go into now Newton's law of motion. We won't go into FBDs. We will just have a nice idea of what those coordinates really mean. Okay, we will just describe them. We will start with the physical coordinates, and then we will what we will do is we will find the kinetic energy, we will find the potential energy, then we will find the Lagrangian of the system, and then we will use the Lagrangian formulation, that formula, and finally find the equation of motion with some caveats, like we will observe that. So here these x1 x2 are not, and x3 is also there, so these three are not independent. That's my point. If it had been independent, then we could have used Lagrangian equation of motion as it is, but since there is a presence of x3 is now some coordinate which I have invented myself. It doesn't have any say to it, but it is just making the system where the constraints are in those coordinates only. Okay, so the first step was to find kinetic energy. This is the kinetic energy expression, then potential energy expression. Now we have to find Ci. Okay, and for Ci we have to find this relationship. For this relationship, first we have to define x3 coordinate, then we have to find differential form. So this is our differential form. Then we have to find these parameters, so which will give us these parameters. How? By using this, and from there actually it's going like this, something like this, from here to here, then from C1 C2 we will put these conditions into here, C1 C2 C3, and now what our equation will get are these. So these are our equation of motion with a additional parameter called lambda, and those are called Lagrangian multipliers, and finally we can solve this equation to get those equation of motion. So this is our final solution. So what does this physically mean? So So it physically mean that C3 was actually a force which was holding that block. Okay. Now, if we found the constant force, we can find the friction force, which was required in that problem, Batman problem. So this is just a way to, in which there is a, you can start with any number of physical coordinates, just that you have to identify what the constraints are, and if you are putting the constraint in this systematic way, you can, if you can code it into some symbolic software, you can convert any physical system into equation of motion with the Lagrangian multiplier into the play. And this Lagrangian multiplier actually in physics, in our case, conveys some physical thing. In our case, C3 was a contact force which was in between the M2 mass and M1 mass. Okay, so just a heads up. Now we can do the same thing using the friction. We haven't used friction, so Fi was not used in the previous question, but now we are using Fi. Same scenario. First we have to solve for this, then we have to put these values in here, and along with this F. Now these are the additional things. Finally we will get the solution. Okay, now time is up. If you have any suggestion, any questions, you can talk. I think there is a lot still left we have to cover, and we will be doing this, let's say, in the next class. Okay, so yes, if you have any doubt anywhere in this course, you can, because this is the interaction class, so in starting of the class or this time end of the class, you can ask away as much questions you can. It can be related to this our course, and it can be outside of this course also, which is related to this topic. Yes, Abhishek. Yes. Not NPTEL. It will be uploaded in my own YouTube channel. It doesn't have that much views, but yeah, obviously you can anytime check out these whatever I have taught. So yes. Okay, it will be shared. It will be shared by NPTEL. Okay. Thank you, Abhishek. Okay. I'm open to questions. You can ask any sort of question. So you can also comment on my terminology. You can criticize also. I will think about it. Last time I had a criticism that the text color is blue, so it was giving less effect. So now, yeah, while looking at my own screen, I can see white works better. So actually, I am making this document a proper document, and I will be putting everything in form of a Batman stories. So this is a new thing which I thought this year, a resolution. So let's see how much I can go. This is the second. I successfully completed, I think, second comics. Now still many to go. But yeah, in any, my main aim is to solve those questions and keep you interested, and also to cover each and every part, and also go into some philosophical view which I have generated in these years of doing research. Like I have experience in about experience for about 7 to 8 years into nonlinear dynamics. By the way, I'm a fourth year PhD student, and 3 years were in my MS IT Madras. So there also I worked into nonlinear dynamics only. So this area fascinates me a lot. So yes, anything, any suggestion is always welcome. So next time what we will do, I will start with the front or the starting thing only. Okay, like what was I have written here. Yes. So this will be our point where we can track down the whatever is left or whatever is the problem. We are currently in development of nonlinear equation of motion using symbolic software, and actually for today I have only covered force and moment based approach and language principle half. Okay. So slowly we will be moving forward, because I had a lot of uh, planning to do before doing this. So yeah, but we will be covering each and every question before time. So because the quiz assignment 2 was right now the priority, now assignment 3 will be priority, which covers solution of nonlinear equation, but those have different level. If you will watch the videos, you will easily get it, but if you wanted to have more in depth, then this 2 hour lecture is there. So okay. I will just have one selfie and then I will just report is posted in my Instagram page. Okay, so if there is no question, I can okay, thank you, thank you, sir.